Good morning all. In this session, I will give you an idea about USB protocol. This is the outline of this session. Initially, I will give an introduction to USB protocol. After, I will explain various connectors and devices in the USB standards. Then I'll give details example of a packet in the USB standard.
USB is an acronym of Universal Serial Bus. It is a serial communication standard and it has a single master multiple peripheral architecture, and the master in the USB terminology is called host, and in USB terminology the peripheral is called as devices, and this is commonly used for communication between computer and various peripheral devices. A computer can have a lot of peripheral devices in order for the proper operation of the computer. For example, a computer has a keyboard, mouse, printer, monitor, etc. And in olden days, each peripheral devices uses different communication interface for communicating between the devices. And so it becomes very difficult for the manufacturers for building and maintaining these interfaces. So so a group of software and hardware manufacturing companies, including Intel, Microsoft, IBM, etc., are created a forum named USB Implementers Forum and started working on the first USB protocol in 1994, and they have released the first USB protocol in 1996, and the first version named as USB 1.0, and it gives a detailed specification of the cable, connectors and protocol used in the USB communication. Nowadays, this USB protocol is maintained by this USB Implementers Forum. USB revolutionized the computer communication methods. If we take a legacy laptop or a legacy desktop, we can see that there is a lot of parallel port, serial port and PS2 port will be present in the computer. But if you buy a new computer or a new laptop or a desktop, we cannot find this port in the PC, because these ports are replaced by the USB port, and we cannot find any peripheral devices which is using serial port, parallel port or PS2 port nowadays. And following are the examples of the peripheral devices that are connected via USB. First example is the computer keyboard and mouse, and this computer keyboard and mouse are used PS2 port for communication, but now they are switched over to USB. Then video camera, printer, portable media player, disk drive and network adapters, all these peripheral devices nowadays using USB standard for communication. After the initial release of USB 1.0 in 1996, USB Implementers Forum released many other versions of USB, and this USB 1.0 support speed up to 12 megabit per second in the full speed mode, and in the low speed mode it is support up to 1.5 megabit per second. And after USB 1.0, the USB Implementers Forum released USB 2.0, and it is released in April 2000, and it is support speed up to 480 megabit per second, and it is a widely used USB standard. And after USB 2.0, the USB Implementers Forum released USB 3.x,
and it is the first version of USB 3.x is USB 3.0, which is released in November 2008, and it supports speed up to 5 gigabit per second in the super speed mode, and in the super speed plus mode it supports speed up to 20 gigabit per second. And very recently they have released USB 4, and it is released in August 2019, and it is a modified form of Thunderbolt port. And in order to communicate in the USB 4, it need USB Type-C connector. There are two types of USB devices. The first one is USB hub and the second one is USB function. USB hub is act like a extension box. So we can attach in the USB hub we can attach multiple hub and multiple function. So it is providing, in other words, it is providing more attachment points. And the USB function can be think as a computer peripheral, and it offers some communication capabilities. The example of USB function is keyboard, printer, mouse, etc. USB has a single master multi-peripheral architecture, and a USB host can connect it to multiple USB devices, and each USB device has a unique address, and this unique address is ranging from 0 to 127 because it is a 7-bit address field, because it uses a 7-bit address field, and but the address 0 is reserved for enumeration purpose. So the device can use only from 1 to 127, so total of 127 addresses. Along with these addresses, USB also the device also need a vendor ID and a product ID for the communication. This vendor ID is obtained from the USB implementers forum, and the product ID is given by the manufacturer. Let us look into the multi-tier architecture of the USB. The top layer of the multi-tier architecture contains the host device or root hub. Other USB nodes and USB hubs can be connected to this tier, and this the hubs and nodes which is connected to the root tier is called tier 1 nodes and tier 1 hubs. And similarly the other nodes and hubs can be connected to the tier 1 hub, and this hubs and nodes are called tier 2 hub and tier 2 nodes. Similarly, it is possible to have up to 7 layers of 7 tiers of nodes and hubs. In USB standards, 3 type connectors are specified: Type A, Type B, and Type C connectors. The Type A and Type B connectors are widely used in USB 1.x, USB 2.0, and USB 3.x standards. And the Type C connector is used in USB 4 standards. But this Type C connector is also used in USB 3.x standard. And this Type A connector is a downstream connector. It means that it is used for connecting to the host device, and it is also used for transferring power. And this Type B connector is more like a square shaped connector, and it is used for connecting to the peripheral devices, and it is a upstream connector. And the third one is Type C connector, which is a symmetrical and reversible connector. And in the USB 4 standard, it is only used Type C connector. Here you can see the wiring diagram of USB port, and the wiring diagram consisted of 2 data lines and 2 power lines. The data lines are denoted as D plus and D minus, which uses through the d plus and d minus, the differential data can be sent. The differential data help to remove the noise in the system. And there is along with the data lines, there is also one power lines also there, and this power line is denoted as V bus and ground. The voltage of the V bus is plus 5 volt and the ground is at 0 volt. Here in this image, the V bus is denoted as plus and the ground is denoted as minus. Depending on the power which is taken from the USB port, the USB devices are classified into two. First one is bus powered devices. The bus powered devices is taking power from the V bus only. It doesn't have an external power supply. And example of bus powered devices are keyboard, mouse, some speakers, etc. This uses only the power of the USB bus to operate. And another type of devices is self-powered devices. In self-powered devices, these devices has external power source, so it consume very few amperes or milliamperes of current from the V bus. USB standard support multiple speed of operation, and the speed of the operation is increasing from USB standard 1.0 to USB standard 4. And here in the case of USB 2.0, the speed are low speed mode, full speed mode and high speed mode, and this speed is ranging from 1.5 Mbps to 480 Mbps. But in order to communicate with these different types of devices, the host need to know what type of devices it is attached to. So in order to identify the devices, device mode, the devices has a pull-up resistor. If the pull-up resistor is connected to D minus pin of the port, then it means that it want to communicate with low speed mode. And if the pull-up resistor is connected to D plus line of the port, then it means that it want to communicate with full or high speed mode. And in order to differentiate between full and high speed mode, full speed and high speed mode, the USB standard uses a chirp signaling, and this chirp signaling will help to find out whether the device want full speed mode or high speed mode of operation. And these pull-up resistors are situated internal to the device, so user doesn't need to worry about the pull-up resistor. Now let's go through the term endpoints. Endpoints are nothing but the data buffers which is situated in the peripheral device, and this endpoints is used for the communication between peripheral device and the host machine. And there are two types of endpoints: in endpoints and out endpoints. The out endpoint is a data buffer which is used to store the data received from the host machine, and the in endpoint is the data buffer which is used to store the data which is to be sent to the host machine. And a peripheral device is allowed to have maximum of 32 endpoints. Out of 32 endpoints, 16 endpoints is used for used as out endpoints, and 16 are used as in endpoints. But it is not necessary to have 32 endpoints for a peripheral device. Sometimes the peripheral device can have only 8 endpoints, or sometimes it can have only 4 endpoints. And here the endpoint 0 is used for control purpose, such as enumeration during the communication. So without this endpoint 0 in and endpoint 0 out, the device cannot function. And this endpoint 0 in and endpoint 0 out is never used for communication purpose. There are 4 modes for USB transfer, and each transfer modes are used for different application. The first mode of USB transfer is control transfer mode. The control transfer mode is used for the configuration of the USB device, and it is used when an external peripheral device is attached to the host device. The control transfer mode will be used. Similarly, when the external device is powered on from the off state, the control transfer mode is used. But this control transfer mode is not used for data communication. And the second mode of the USB data transfer is interrupt mode. The interrupt mode is used when it is required that when the latency, in order to reduce the latency between data transfer. And in some situation, it is desirable to have very low latency. For example, in the case of keyboard and mouse, the data generated by the keyboard and mouse should be immediately transferred to the host computer. Such cases, interrupt transfer mode is used. And in the case of interrupt transfer mode, the maximum payload size is 64 byte for LS low speed and full speed devices, and the maximum payload size can be up to 1024 byte for high speed devices. And the third mode of USB data transfer is bulk mode. Here in the bulk transfer mode, the data transfer is scheduled over the free bandwidth. When a free bandwidth is available, the bulk mode will execute the scheduled data transfer. And in bulk transfer mode, the maximum payload size can have up to 64 byte for low speed and full speed devices, and it can have up to 512 byte for high speed devices. And the fourth mode of data transfer is isochronous mode of data transfer, and this isochronous mode of data transfer is used for streaming devices and in the real-time application. So for the streaming, there is no error correction is required. Depending on the application, we can choose different data transfer type. And in the case of human interface devices or HID devices, it is better to use interrupt transfer mode, because HID devices like mouse and keyboard generated data, and this data need to be immediately transferred to the host computer. Such cases, the best low latency is given by interrupt transfer mode. So we preferred interrupt transfer mode over other type of data transfers. And in the case of mass storage devices such as pen drive and hard disk, it is better to use bulk transfer mode, because bulk transfer mode allow the transfer of lot of data without any error. And in the case of communication class devices such as serial to USB converter, we are going for interrupt and bulk mode of transfer. Now let us go through the USB transmission. The USB data is transmitted by toggling the data lines between J state and the opposite K state. The J state and the K state can be represented by the voltage level in the D plus and D minus lines of the USB cable. Here we can see that if the D plus is low voltage and D minus is high voltage, it can be represented as a K state. And similarly, if the D plus is high voltage and D minus is low voltage, this state can be represented as J state. For the USB data transmission,
the non-return to 0 inverted line encoding is used. And in non-return to 0 inverted line encoding, 0 bit is transferred by toggling the data line from J state to K state and vice versa. And 1 bit is transferred by leaving the data line as it is. And we will discuss this NRZI line encoding in the next slide. And there is one problem will be associated with the NRZI encoding. It is that if some consecutive 1 bit is occurred, the data lines in the USB port will maintain its voltage level to a constant value. And if such thing happen, the clock recovery circuit in the peripheral devices cannot recreate the clock from the data. So in order to prevent that issue, we will use a bit stuffing technique. In the bit stuffing technique, we will add an extra 0 bit after 6 consecutive 1 bit. Now let's go through the NRZI encoding or non-return to 0 encoding. And in NRZI encoding, we can transmit 1 without changing the level of the output. And if you want to transmit 0, we need to flip the voltage level at the output. Here we will see there are two lines. First is the input line, data, which is the data, and second is the NRZI encoded data, which is the output. And initially both the data and the NRZI encoded data are at a high voltage level, and after some time sometimes the data is changed to 0. It means that we have to flip the voltage level to this NRZI voltage level to a 0 voltage. It also need to be flipped, and then data is changed to logic 1. Logic 1 means there is no need to flip the data, just maintain the voltage level. So here we maintain the voltage level to same as 0. Then again 1 come. So it also here also we need to just maintain the voltage level to the previous voltage, that is 0 volt. And then it is come 0. It means that we have to flip the voltage level. So we flip the voltage level to 1. Then it come 1. So 1 means we just have to maintain the voltage level at the previous value. So we are maintaining the voltage level at the 1. And then it comes 0. It means that we have to flip the voltage level. So we flip the voltage level to 0. Then it come 1. So we maintain the voltage level at the previous 0 voltage. Then it comes 0. So we flip the voltage level. Then again comes 0. So we flip the voltage level again. Then again comes 0. So we flip the voltage level again. Like that, the NRZI can be encoded like this format. This is an example of USB 1.1 full speed device transmission. Here we can see that there are three field for the packet. First is the start of the packet field, which is represented in this yellow color, and second is packet ID. This is represented in green block, and finally the end of the packet field. This is also represented in yellow. Now let us see the USB packet fields in details. The first field of USB packet is sync field, and the main purpose of sync field is to synchronize the data between transmitter and receiver. And for a USB low speed and full speed devices, sync field consists of 3 KJ pairs followed by 2 Ks to make the 8 bit of the data. And for high speed devices, the sync field consists of 15 KJ pairs followed by 2 Ks to make up 32 bit data. Here we can say that this is a low speed device, and it has the sync packet consists of total of 8 bit long. So here we can see that there are 3 KJ pairs and 2 Ks, which make up the sync packet. The packet identifier field comes directly after sync field, and it consists of 4-bit identifier followed by 4-bit 1s complement of the identifier. Here we can see that the packet identifier, which is shown in green block, which is totally 8 bit long, and the packet identifier is the first 4-bit, which is 0101, and it is followed by 1s complement of the packet identifier, that is 1s complement of 0101, it is 1010. So overall 8 bits. After packet identifier field, it come address field. It is a 7-bit long field. Since it is a 7-bit long field, it can address up to 2 raised to 7 devices. So 2 raised to 7 equal to 128 devices. But the 0th field is 0th address is reserved for control purpose. So it can access only 127 unique devices. And after address field, it come endpoint field. It is a 4-bit long field. So it can access 2 raised to 4 equal to 32 endpoints. And in 32 endpoints, endpoint 0 is reserved for control purpose. And after endpoint field, next come data field. The data field is used to carrying data, and it is ranging from 0 to 1024 bytes. After data field, the next comes CRC field. CRC field is used to detect error in the packet, and CRC is denoted as is the short form of cyclic redundancy check. So CRC field consists of cyclic redundancy checksum of all the packet. And in the case of start of a frame packet, CRC field is only 5-bit long, and in the case of data packet, the CRC field is 16-bit long. After CRC field, next field is the end of the packet field. End of the packet field denote the termination of the packet, and it consists of single-ended 0 for 2 bit times followed by J for 1 bit times. USB protocols uses different type of packet for different applications. There are 4 types of packet which is supported by the USB protocol. The first packet is token packet, then data packet, then handshake packet, and finally start of frame packet. This is the basic structure of USB packet. In here, the token packet is used for the control purpose, and the data packet is used for sending data, and the data packet is the largest packet of all four type of packet. Thank you.